Okay, so here's F-1, and this, the next three phases are about something called L'Hopital's rule. So it basically says this. So if the limit as x approaches a of f of x over g of x, if this ends up, when you direct substitute, if you end up getting 0 over 0, then by L'Hopital's rule, this original limit is equal to the limit as x approaches a of the derivative of the top over the derivative of the bottom. Yeah, so never mind, that's okay. Okay, so and then so basically if you do direct substitution and you end up getting 0 over 0, you can apply this rule. But there is another case. Here's the second case. If, same situation, you end up with infinity over infinity, but also negative infinities would work too, then by L'Hopital's rule, the same thing. Okay, when I say same as above, this means that you would want to do the limit of, so the derivative of the top over the derivative of the bottom. Okay, so that's what you would end up with. Okay, so we're going to use this rule. So we're going to evaluate this limit. So this example is not from your practice, but then the next example will be. Okay, so what is going on here? So you want to like direct substitute. So think of like plugging in infinity. So you would get e to the 3 times infinity. That would be e to the infinity, which is infinity. All right, so you would end up with infinity over infinity. All right. Now, once you end up with something like this, infinity over infinity or 0 over 0, those are called indeterminate forms. Okay, indeterminate means you can't determine really what it is. So you have to do something like further to actually like investigate what it is. So if you get infinity over infinity or 0 over 0, you can't say anything yet. So I'm going to go like this. All right, so since we've got infinity over infinity, I'll do it like this. I'll say therefore by L'Hopital's rule. Sorry if my handwriting's bad. I was just walking outside and it was cold. Therefore, by L'Hopital's rule, and I'm going to put like an arrow. So I don't have to write this again. I'll just put like an arrow to this original limit. So therefore, by L'Hopital's rule, this original limit is going to be equal to the limit as x approaches infinity of the derivative of the top over the derivative of the bottom, okay? So, oh, and this, by the way, guys, I went to like this AP Calc like training one summer, and this is not focusing. And they made it very clear to us that if you're going to use L'Hopital's rule, you need to state this, therefore by L'Hopital's rule, otherwise you won't get credit for it. So if you're going to use L'Hopital's rule, you've got to state therefore by L'Hopital's rule. And when we're doing our practice, it's okay maybe if you just say but therefore by LH rule, or I think LHR, therefore by LHR, the students last year would say. But when you get to the AP test or when you're taking a test, you've got to write out L'Hopital's rule. If you misspell it, it's okay, but an abbreviation wouldn't cut it. All right, so this is equal to the limit as x approaches infinity. Okay, now the derivative of the top. So yeah, so over here I'll be like, all right, e to the 3x. All right, I'm taking the derivative of that. I need chain rule. Okay, if it were just e to the x, it would be just e to the x, but it's e to the 3x. So you don't have to do this, but in, out, so 3x e to the blank, you don't have to do the chart, e to the 3x. Okay, so the top is 3e to the 3x. That's the derivative of the top. And then the derivative of the bottom is just 2x. Okay, and then you try to direct substitute again. All right, so you're plugging infinity in for x. 3 times e to the infinity, that's 3 times infinity. That's infinity. So the top is infinity. The bottom, 2 times infinity, that's infinity again. All right, so I guess at this point, okay, so guys, we end up with infinity over infinity again, so we can apply L'Hopital's rule again. So I'll say, I'll be like this. I'll say, therefore, by LHR, since I already wrote out L'Hopital's rule, if you just say this on a test by LHR, you're not going to get credit. But if you've already written out the words and then you abbreviate, your reader is going to understand that this means L'Hopital's rule. Okay, so therefore by L'Hopital's rule again, and I'll be like, okay, I'll say we have the limit as x approaches infinity. All right, so I'm going to do the derivative of the top over the derivative of the bottom. So the derivative of the top, so this time I'm taking the derivative of this, all right? So inside, outside, so 3x, 3e to the blank. The derivative of 3x is 3. The derivative of 3e to the blank, this 3 is a coefficient, it just comes down. E to the 3x, so that's 9. E to the 3x over just 2. Okay? And then you're plugging like infinity in for the x. So that's 9 times e to the infinity. That's 9 times infinity. That's infinity. Infinity over 2. Yeah, so we end up getting a limit that doesn't actually exist. You know, because a limit only exists if you get like a concrete number. So we end up getting infinity. Yeah. Okay, so there's that, guys. Now, on your practice, I don't think you'll have to apply L'Hopital's rule more than one time. It's typical to only have to apply it once. But I just wanted to show you an example of if you had to apply it more than once. Okay, so let's do this one. All right, this is number 12 from the practice. The first thing you try is direct substitution. So we got the limit as x approaches -1 of this. So I'm direct substituting, so I'm dropping the limit. This is 2 times natural log of, I'm plugging -1 in for x, so that ends up being 1, over, this ends up being e to the 0 minus 1. Okay, now it's a good thing, guys, if you think about y, but this should be something you know from the past. The natural log of 1 is 0, okay? Because remember, a natural log, you'd be thinking like e to the what equals 1. E to the 0 equals 1. Okay, so the natural log of 1 is 0. Yeah, so this ends up being 2 times 0. All right, so I'll say note. And also, guys, e to the 0 is 1. So we have 2 times 0 over 1 minus 1. This is 0 over 0. Guys, that's an indeterminate form that's going to allow us to use L'Hopital's rule. So I'll say, therefore, by L'Hopital's rule, and in practice, I'll say when practicing can write LHR. But not on a test, guys. On a test, you've got to write it out for credit. The AP people won't give you credit. Okay, therefore, by L'Hopital's rule, we can take this, and it's going to be equal to the limit as x approaches -1, and I'm going to do the derivative of the top over the derivative of the bottom. Guys, this is an optional step, okay? You don't have to write this step out. I'll say here optional step, optional step. I'm just doing it in the notes so you could actually see the rule, see what the rule is. Equals the limit as x approaches -1. Okay, now I need the derivative of the top. So, all right, so for the derivative of the top, I've got to do this, I guess. So the inside would be -x, the outside is 2 natural log of blank. The derivative of -x is -1. The 2 is a coefficient, it just comes down, and then derivative of natural log, and then -x goes in there. Now actually, guys, these negatives are going to end up canceling, so the derivative of the top is 2 over x. All right, now for the bottom, okay, for the bottom, the derivative of this, for the derivative of this one, of this term, we're going to need chain rule. But for the derivative of this term's derivative is going to be 0 because that's a constant. So, and guys, you don't have to write the chart. It's better if you could do it in your head without the chart, but write the chart until you're confident that you're going to get it right without it. So derivative of inside is 3. Derivative of outside is e to the blank. So 3e to the 3x plus 3. Okay. And now I do direct substitution. So I'm plugging in -1. So this is 2 over -1 over 3e to the 0. So this ends up being -2 over 3. Okay. All right, guys, talk to you later.